So on that worksheet, so today it's just the worksheet, you're just going to work on it. Hopefully you watched both videos. There were two, so there's a little issue with the notes quiz because some people hadn't watched the second video. So then, and I did set it for twice, so I'm hoping they went back. Today you're just going to work on the worksheet. When you're done, probably in class today, I assume you shouldn't have homework. Those of you in the room right now. At home, I anticipate this worksheet taking maybe half an hour-ish. And I purposely have it built in for being finished in class so I can help you if you're stuck. So this is just work the issues out after watching all the notes and then submit on the Google form. So on that worksheet, I'm just going to kind of go through and talk about all the different types of analytic, which means algebraic limits. So on this, from yesterday's notes, what's the very, I can't walk too far away from, I don't have my mic on, so it's picking it up from the computer. I hate being tied up here, but what's the very first thing you do when you're taking a limit, no matter what?
Good morning, Elk River High School students and staff. This is Ms. Ogren, and I would like to share some information about today. We will be participating in a variety of safety drills throughout the day today. School safety is one of our top priorities, and state law requires all public schools to conduct various drills during the school year.
Sorry, guys.
Staff will be facilitating scenario-based drills today, and as part of these drills, students and staff will review video modules and have class discussions. The goal of the drills are to learn together and practice various responses to emergencies and threats. We will also evacuate the building to practice fire drills. When outside, please make sure we continue our social distancing. In the spring, we will conduct the remainder of the drills, including the severe weather drill. Thank you for your cooperation and participation today.
All right, so what's the first thing we do when we're taking a limit at a constant like this? What do you do with it? Plug it in. And if you get any number, it can be 0, right, or 5 or pi, any number that's your limit. It means that's where you are on the graph. If you get a 0 in the denominator, then you know for sure there's one of two types of issues. So you look at number 6, there's a 0 in the denominator and in the numerator. From the notes, what did I say that means happens on the graph? There's a hole in the graph, right? But you're there. So just because there's a hole, because it's, it's continuous, you're there and that's your limit. So for these, there's like 3 different ways. You factor, you cancel, you find the issue. Like for example, number 7, the issue is going to be at 1. So you know there's an x minus 1 on the top and on the bottom, right? Notation-wise, though, make sure that you're not just doing it in this class, you have to have good notational fluency or you don't earn all the points. It's not that they get taken away, it's just that on the rubric for the AP exam, it might say proper notation +1. And if that's one of the 9 points on the FRQ, you won't get it even if your answer's right, if you don't have proper notation. So we'll go through number 10 together, just because this is one of the more confusing kinds, and I want to make sure you have the notation down. So with number 10, when I directly plug that 0 in, on the top I get a half minus half, and I see that it's 0, and on the bottom I have a 0. I know there's a hole in the graph, right? I actually know the x-coordinate of the hole is 0, because 0 is what's causing the issue on this one. On this one over here, the hole's at 3 comma something, because 3 is what's causing the issue. So I know on number 10 that actually x is going to cancel. On number 11, I know x minus 3 is going to cancel. Does that make sense? So what I do on this one is you have to keep writing the limit. If you don't, you won't get the notation point. So it's not getting it done fast and getting the right answers. That's good. But you also need to make sure that you're writing the correct amount of work to earn all the points. So you don't drop your limit till the very last step. Except on those first ones on the first page, because the first step is the last step. All right, so in the notes I said that when you have this complex fraction, I use the phrase crisscross applesauce. If you like to get your common denominator a different way, go ahead. But you need to get rid of the complex fraction. So I said you just grab the top left, multiply it by the bottom right. You keep the link, and this one it's a subtraction problem. Then you go on the cross, which is x plus 2. Then it's all over, and you multiply. You do x plus 2 times 2. That's the entire numerator as a single fraction. Does that make sense? And then you divide it by x. Well, when you divide by x, you multiply by 1 over x, and that just keeps it on the bottom, so it just sort of all collapses to the bottom. Now, if you look at the top, the 2 minus 2 goes. Don't drop your limit yet, though, because I'm not done. So you do, this does get kind of tedious having to write that limit, but you have to. So it just is what it is. So the 2's cancel, and now you'll notice on here, I knew x was my issue. I knew it was going to cancel. Do you see how we just found it? So gone, gone, -1 is left on the top. And now I plug the 0 in. Now I can drop my limit because I'm at an answer of negative what? What's my answer? Negative? 1. There's a 2 out front here. It's 2. Yeah, I kind of slashed through that 2 by accident. Yep, -1/4. That's the limit. Now keep in mind what that means. You just found where there's a hole in this graph. It's at the point 0, -1/4. So fire drill. Guys at home. Whoops. You can go out and go to the right. I just gotta turn this off so it's not. Oh my gosh. People at home, we're heading on, we had a fire drill. Heading on over to number 14 to discuss piecewise because I skipped it in the notes. And then it's just gonna be work and we're gonna kind of figure out who individually needs what. So on number 14 with the piecewise, this notation means your x is approaching from the left of 2. So it's kind of the piecewise notation for coming in from the left, you're on this parabola. This is coming in from the right, you're on a sine wave. Does that make sense? So what you do in this case is you still need to check if the limits match because you have 2 things meeting up. So if the parabola comes in like this, and that's at 2 comma something, and then the sine wave picks up and goes like that, then you would say the limit doesn't exist. But if they match up, so like if this sine wave meets up right there, then the limit exists. So it's actually quite easy. You still though need to take the limit as x is approaching 2 from the left of f of x. That's just on the parabola. Where are you? So you just go plug a 2 in there. And when I do that, I'm at 0. All right? So 2 comma 0 is on the parabola. So that would be like 2 comma 0 right here. That's the parabola. Now when I go to the sine wave, I still am taking, and notice I'm using limit notation. It's not actually on this one. It's kind of threefold. Go fairly quickly, be accurate, but also keep your good notation going. So this would be of f of x would equal. And again, you just plug the 2 in for x. So I'd be at 2 pi fourths or pi over 2. So right here, you have to be 100% sure what the sign of pi over 2 is because a wrong guess is probably going to lead you to the wrong answer. Because what is the sign of this one right here that pi has? Go ahead, you can tell me. No. See, that's what I mean. And if you mistakenly said the most common mistake, you would have said this is 0, and then you would have said the limit 0. Do you see? So it's actually a huge deal, this unit circle being accurate, because the sign of pi over 2 is actually 1. So this sine wave is up at 4. What that means graphically is it's up at 4. So when I came in from the right and the left, they didn't match. So what do you write for your answer? D and E. Yeah, so that was a good choice. All right, so you guys get to work the rest of the hour. Keep good notation going. If you have any questions, let me know. And there is a full key in Schoology. You might want to do a page, check a page, but really make use of that key. Which two, you two wanted to go work together? Go ahead.
Close room.
Yes.
Okay.
And what's your name again?
Cameron.
Cameron, I knew that. Yep, you can go there. If he sends you back, that's fine. Keep.
Okay.
Did you guys have him last year?
Yeah.
Oh, I'm gonna stop recording.